Hello, my name's Simon Bingham and this is part of my video series on OSPF. Okay, in my previous video I gave a quick demo of how it's possible using Dijkstra's algorithm to come up in effect with a routing table. My point was really that if we can come up with in effect a map, then we can run an algorithm through it and that can end up being our routing table. Now, moving on to this, I mean, obviously we're not really dealing with maps, we're dealing with networks. There's some additional complications. Now, one of the main complications is that Dijkstra's algorithm cannot cope with a multi-access type scenario. So it can't deal with this. So when you've got a number of what we call vertices joining together in a single point, Dijkstra's algorithm can't cope with this. It just doesn't work. So when you have a network, as you and me know it, maybe connected together, say via a switch, say we have a number of routers connected together via a switch, and it becomes a shared segment, we need some sort of ploy for dealing with this and converting this into a format that Dijkstra's algorithm can process. So the way of dealing with this is to create, if you like, a sort of pseudo node, or if you like, to describe the network as a thing itself, as a point. So this, I know this sounds a bit odd, but you just imagine this. We can actually say, well, there's a network 192.168.0.1, and we can describe that as a point of vertices, and we can say to get to that network there's a certain cost, and say from 3 to that network there's a certain cost, and from that network there's a certain cost, and then off that network there's a certain cost, and we can treat it just as if it was a router. What we're really doing is we're breaking the shared link down into really three, point to point is probably the wrong word, but 3 direct connections. So let's just move on. So with that understood, that will lead on to some of my points I'll make in a minute. And let me talk about how, for some of the more nuts and bolts about how OSPF describes its surroundings. Well, OSPF uses a number of mechanisms called LSAs, and I'll go more into LSAs in a minute, but this will map to a particular LSA. So I'm going to describe something called the router LSA. Now, the router LSA is the first way that OSPF begins to describe its surroundings. And a router, in effect, sends out this LSA, and it contains information about this is me, and this is who I'm connected to. Now, it could say in one case it can say I'm connected to a particular neighbour. In another case it can say I'm connected to a particular network. In another way it can say I'm connected to a transit network. Anyway, this will become a bit clearer as I work through these slides. Now, remember I said that Dijkstra's algorithm can't really deal with multi-access networks. So where we have a shared network, and let me just make this a bit bigger. So where we have a shared network, like the example I gave before, in effect, Dijkstra's algorithm has to break this down into, if you like, a new node or a new thing that the algorithm can consider, and it breaks, in effect, makes this a set of different point-to-point links. Now, how do we do this? What's the actual mechanism for doing this? Well, actually, the routers on a shared segment elect what's called a designated router. Now, again, I'll come on to that later on, how you elect a designated router. I don't want to get bogged down in that here. But what I really want to get across is okay, so now we have this new type of LSA. So I mentioned a router LSA. We have another type of LSA called a network LSA. Now, a network LSA really tells you we're describing a shared segment. And what happens, remember I said the elected designated router, in effect, is the one that takes responsibility for advertising this and bringing this into the whole system. Right, so this may seem the wrong way around to some people, but I think the best way to show these things is by example. So what I've done is I've got a couple of routers in my lab here, and we can view here, we can view the database right in front of me. This is database. I've just done a run show OSPF database detail on a Juniper router. Now, what we're going to do is we're going to work through this, and I understand it may seem like we're jumping the gun a bit, but I actually think this is a good way to see what's happening. So this is a database. It's being displayed on one of the routers, but this should be identical on every single router, and this is how the routers in effect describe their world. So we have a router here, and the ID of the router is 2. 2.2.2.2. And what this router is doing is, this is actually, if we should go through this, this is our first LSA. Now, this LSA is described as a point-to-point link. So let's just start drawing this out. So we have, let's make this as small as we can. I'll try and keep everything on the screen as best I can, but it's not going to be particularly easy. So let's just say we have a router, and it's called 2.2.2.2. Right, and it is saying, now look here, now we have a point-to-point link, and it has an ID of 4.4.4.4 and a data of this address here. So what does that mean? Well, actually, depending on what type of link it is, so it's told us what type of link it is, tells us what the data is. So I just said it was a point-to-point link. It had a link ID of, oh look, someone else's, so it's saying my neighbour is called something else. So 2.2.2 has a neighbour of 4.4.4.4, because that's what it says there. Look, it says 4.4.4 is my neighbour. So let's just draw that in the diagram here. And so we now know there's some sort of link between these two devices, because it's just told us that. Right, let's read the second part. So it has data of 192.168.30.13. So what is that telling us? So it tells us, look, it's a point-to-point link. It's describing the local IP address. Okay, so let's whack that in the diagram as well. Excuse me. 192.168. What did we say it was? We said it was 30.13. 30.13. We're going down here. This is the information that's been sourced by this. We're still looking at 2.2.2 here. So we've got a link ID. So we've covered that already, and it's a metric. Oh, that's interesting. A metric of 1. I'll come back to that in a minute. Now we've got another link ID here. Now look, the first thing to look at is it says it's a type of stub. Now, remember before I said that point-to-point networks are a bit strange. They advertise a link. They in effect say that they're neighbours, and that's what we're seeing here, this point-to-point. But it's also going to describe something else. So, what does a stub describe? What do the data fields describe? Where it says the first bit is a network number, the next bit is a subnet mask. Network number, subnet mask. Okay, so we know we are connected to 192.168.30.12, and it was a /30. Okay, this is the information according to 2.2.2. And there we go, we're finished. Okay, because we've already kind of got 4.4.4 in the diagram here, I'm going to actually jump over one of these and just jump straight to this one, and we'll go back to that in a minute. So 4.4.4.4 has described itself as having a first one is here. It says it's got a transit type of transit link, so describing its links here. And if we look at transit, we can see that a transit network, the link ID is a designated router's IP and the other part of so the link ID is the DR's interface IP and the local IP address. Okay, that's interesting. What I'm going to do, I'll switch to a different colour here just to make it clear what is being described by what device. So let's just change that to blue. So this is saying that the designated router, let's switch to blue, the DR is equal to the transit DR's interface IP. So we're looking at this is 192.192.168 is that. There we go. Right, and it is also saying that my local address is .1. So that's one of the links described. I should say, if this seems quite long-winded, I do think this is quite key, because if you understand this, they love asking questions about this, I would imagine, on exams. Certainly if I was writing exam questions, I would be asking about this kind of thing. And really your ability to read through this and interpret it is quite key. So let's have a look. So let's look at the next LSA. So it's got point, straight away we can see it's a point-to-point. So if you remember before, a point-to-point describes the neighbour and its IP address. So this is saying that I have a neighbour that is 2.2.2.2. There it is there, look, saying my neighbour is 2.2.2 and my local IP address is 192.168.30.14. Now I hope I'm not confusing things by doing two arrows here, but in a way all these networks are bidirectional. I mean, Ethernet's bidirectional, and when you configure metrics, you configure them on a particular port, and so really it is all two links in each direction, even though you may not see it because you've got a Cat5 cable or whatever you're dealing with. You know, we're nearly always dealing with two directions of communication. So what else do we see here? We see a stub. Now if you remember a stub from before, it said it uses the network, it describes the network number and the subnet mask in effect. So we've got stub, network number, subnet mask. So 4.4.4 is described exactly the same but in the other direction. Okay, now let's move down here. So we've done that. Now what also something worth pointing out is that we have here, we have the metric here going onto this link is 100. Let's just put that on there. And also that's a point to point, let's talk that down as well. Right, now let's jump back to 3 because that seems to be missing from this diagram that we have here. So router 3 is describing that it has two links in its linked database. So we're describing two links here. We're describing a stub of 192. So let's just start drawing that out. .3.3.3.3. Let's use a different colour again, shall we? Let's use the colour green, eh? Right, we'll choose green. So what are we describing here? Okay. So we have a stub link. So a stub link advertises its link to a network and its subnet mask. So we don't really know which way this is going at the moment, so it's just let's just put that in there. And we said that was oh, so it says it's at 30.4. Not something we've seen yet. So 30.4 and it's a slash 30. Right. What else do we have? We have another link which is a transit type, and that has as a transit it advertises the designated router and then its local address. Transit DR's IP, yeah, the designated and then the local IP address. So let's just stick that on here. Oh, and look here, the DR that's being advertised here, if this is router 3 we're looking at, the DR that's advertised is that address there. Now we've seen that before, but that's here. Just copy that. So this is saying that's my DR, and funnily enough, it's also saying this is my IP address. So we can see straight away that router 3 is the designated router on this link. Now we can clearly see from the networks that what we have here is these two are actually connected to one another. Okay. It's worth doing this to get it right. I don't spend too much time filling around this diagram, but anyway, you get the picture. So we're beginning to get a map now up here of this network, and now you can basically see from these elements, from these router LSAs and from these network LSAs, you can basically begin to draw a picture. Oh, I've missed one out. That we have the network, finally the LSA we have at the bottom here, look, we have this network LSA. Now what the network LSA does is it really, if you remember, it was to describe this here. So if you had a number of routers connected off the same network segment, you would describe them here. As it happens, we've only got two on a shared segment. So you can see here it's saying, aha, you've got a mask of, it's saying we have a mask of a /32 in this network, and we can look here, it's saying the attached routers to this network are 3.3.3.3 and 4.4.4.4, and that's it really. So we've basically drawn together all these bits of the jigsaw out of the database and pulled them into a diagram. Obviously I don't want to, I could have had another router hanging off here, we could have gone on forever, but I imagine this video is long enough already. But hopefully now looking at this you'll have the confidence to sort of say, right, I can look through a database and I think the key thing here is to actually memorize this bit here, because obviously the link type, depending on the link type that you're describing, it really tells you what the data is. So it's quite important to memorize this here in order to give, to have the ability to interpret this. And as I said, I mean, I'm repeating myself here, but I would imagine they love asking questions about this on exams. And this is the kind of stuff which really allows you to troubleshoot. If you can if you can look at database and you can work out a picture of the network, then you have a powerful debugging tool at your disposal. Okay, thank you very much and goodbye.